Assalamualaikum warahmatullahi ta'ala wabarakatuh, and good day to each and everyone. So these videos will be the first lectures that we will be having in this EE74. Okay, so sorry for our last or previous classes that not has been completed. So supposedly this topic should be discussed on our prelim coverage, but since I have a um, seven subject of preparation, I was not able to all discuss simultaneously my subject handled. Okay, so but since no inshallah this midterm coverage should be properly taken care of, no, so we should try to fully discuss all the coverage that has been or that has to be done in this course. Okay, so and then in this subject, no, I don't have a exam, but I have only one exam, no, the final exams and the machine problems. Okay, so that would be the final exams, and that would be taken care of after or uh, after the final exams date. No, okay, so um, and then for its machine problems, no, for the machine problems that uh, we have to have in the subject, um, we need to install what we call the MASM, or yung application for programming, no, we have the assembly language. Okay, so inshallah magbibigay din ako ng tutorials on how to install that one, and of course you can also get your own copy of installer sa akin. Pwede kayong kumuha ng installer sa akin actually. So may MASM tayo rito na application, so pwede niyo kunin. Okay, so that is actually for assembly language programming. Okay, so basically this E74, the uh, uh, computer organization and architecture, okay, basically talks about the um, assembly language, no, of programming. Okay, kasi most of the programming that we have having as of now is yung tinatawag nating high level language. Okay, so dito low level yung language yung gagawin natin, kasi ito yung mga dati pang programming na ginagamit ng mga engineers. Okay, marami to siyang application or current application, marami yan siya actually, no, just like yung PLC, ina-apply din natin yun siya. Okay, so now okay, so wag niyo munang pansinin itong mga kakuan dito, okay, kasi hindi to sa akin, no. Itong PowerPoint na to is siniram ko lang to siya sa kuan, so pero since sim lang naman tayo ng coverage for this kuan, for this semester, so ito na lang ginamit ko, pero hindi ko muna um, hindi ko ginamit yung um, hindi ko actually binago, okay, yung itsura niya. Okay, so we have here a typical digital computer, no. So um actually when we are actually talking about a programming, we have here the CPU, the memory, and the system bus and IO devices. When you say IO devices, that is actually the input and output devices. We are actually having that one to output or to input some information, okay, from the users, or from mismo sa system natin or sa computer papunta sa users. Okay, so dalawa yan siya, it may be input or output. Okay, so we have here CPU, no, meron tayong program counter, instruction register, decode, data registers which is BCD, accumulator AC, arithmetic logic. Okay, so yun. So we have here memory, I/O devices, circuit, keyboard, printer, and etc. Okay. So a typical accumulator-based computer, no? Ito yung itsura ng computer that is actually accumulator-based. Okay. So now dito tayo sa memory. Memory stores the program and data they process. So okay. So lahat naman siguro ng mga machines is actually has a memory, no? So basically its definition, it stores the program, it stores the data, no? And they process, stores the data that has been processed. Okay. And I/O devices is we have transfer information between the computer and the outside world. Okay, so yun yung I/O devices. Yun yung sinabi ko sa inyo kanina. Okay? And then fetch and execute. So usually, no, when we are actually the basic function, basic operation that has always happening in programming, especially for high level language, low level language, no? Ito yung fetch and execute, okay? The sabi dito, the CPU continuously perform the operation fetching instruction, executing instruction. When you say fetching instruction, so those instruction na kuan palaging ginagawa ng computers natin or yung executors natin na kumbaga pinapa-feed niya yung function ng isang instruction at the same time. Okay? So yun. So or kumbaga uh, yung operation that has to be taken by the instruction is to be fetched, okay, using the kuan no CPU. Okay. Okay, so that is actually fetching instruction. And for executing instruction, that's actually the output, no? To output or to have the output of the instruction or to execute the instruction itself. Okay. So we have here a typical digital computer. So ito yung examples ng program, okay? So ito yung examples ng programs na meron tayong ginamit na register, meron tayong ginamit na accumulator, and meron tayong ginamit na system bus. Okay? Okay, so as you can see here, dito actually nangyari yan sa memory, no? All of the programs that you are actually having here is nasa-stored yan siya sa memory. That's why in here, um, when you say that in zero, ibig sabihin nun, mag-i-input ka ng mag-i-input ka ng variables doon sa zero port. Okay? So when you say zero port kasi yung sa kuan natin, bus natin or sa I/O devices natin, meron tayong by port diyan na kuan no or yung sa chips natin, mayroon tayong port 0, port 1 up to some given value of port, no? So when you say I in 0, so we are actually having to input some variables in port 0. Tapos move BA, so ibig sabihin yan, i-move down natin yung value na na-stored sa A na-stored sa A doon kay B. Then after that, i-input na naman natin yung pangalawang variable sa port 0. Tapos i-store natin sa A. Tapos i-add natin yung B na na-stored, yung i-transpose natin kanina. So tapos, no, yun na yung actually yung example. So ibig sabihin nito, add to siya na kuan or addition instruction to siya na types of instruction. Okay? Yun. So makikita niyo siya dito sa fetch and executes. Okay? So yun. So we have here three bus architecture. We have address bus carries the address when reading, sending data from two memory or input or output devices. No, so yun yung mga address bus. Kumbaga ito yung nagsisilbing daanan or um, nagsisilbing hindi magkagulo yung process na nanggagaling sa CPU then memory to CPU or I/O devices. So yun, address bus. And of course, we have here data bus. No, this carries the data that is being sent or read from or to memory I/O devices. No, so yun. Okay, so we have here control bus. So for control bus naman, syempre, hindi naman natin pwedeng gawing simultaneously yung address bus and data bus simultaneous na nangyayari. meron tayong tinatawag na control bus, no? Or control the flow of address and or data. Okay. So we have here instruction set and programs. The CPU has the ability to understand and execute instruction based on a set of binary codes and each representing a simple operation. Okay, so computer is actually no, yung sinasabi natin kanina na low level language or assembly language nako-convert when we are actually inputting some instruction sa CPU, okay, nako-convert yung instruction na yun sa binary codes, no, which is that codes is yan yung naiintindihan ng kuan natin, no, na yan yung naiintindihan ng ating computer. Okay, then it transmit from binary codes to uh, sa register, then yun, ini-execute na yun siya. So we have instruction, we have arithmetic, add, subtract, we have logic and or, pwede rin siya data movement or branch operation. Instruction are represented by a set of binary codes called instruction set. Okay, so yung mga ginagawa natin or pinoprogram natin na mga machine problems, no, yung tawag doon sa sinusulat natin is yun yung instruction set. So mamaya may papakita ko sa inyo na examples of instruction set. We have a series of instruction combined to perform a meaningful task is called program. So a series or combination of instruction to provide a meaningful program, a meaningful task. Okay? So ibig meaningful task is tinatawag niya siya as program. So yun to yung tinatawag nating program. So the combination of instruction to form a meaningful task. Kumbaga, for example, meron kang robot, tapos giprogram mo yung robot na yun na uh, gigisingin ka niya kumbaga sa morning. And yan yung rotation niya in every morning. So yun yung tinatawag nating program. Okay? So we have computer programming. We have creating, writing sequence of instruction or commands to instruct the computer to perform a particular task. Okay, so yun. So we have to program or we have to give an instruction of combination of instruction to fully instruct the computer to perform some particular task. Okay, so yun yung computer programming. Okay. So we have here types of computer. We have the first generation computer. So pakibasa na lang yun siya. We have here the second generation computers, the third generation computers, and the mainframe particularly. Okay, and then the mini computers, microcomputers, until na dumaan na tayo sa personal computers or microcomputers. Usually these personal computers is parang kumbaga, okay, particular example of that one is this Altair 8800, no? So ito yung types of computer in which we don't have monitor, but it actually performs some instructions that being given through instruction, no? We have a complete computer based on particular microprocessor chip lang yun siya, kumbaga. Okay? So we have here personal computers or microcomputers. Ito yung pinaka first niya na type or first configuration. Ito yung tinatawag nating uh, uh, ito yung first na configuration ng Apple 1, no? Could be program in basic lang naman din siya. Okay, so the other one here is IBM's or personal computers. Okay? Pakibasa na lang. Okay, then dyan na actually nagsimula yung microcontrollers, no? Usually yung basic yung computers natin as of now is composed yan siya ng microcontroller. Okay? So when you say microcontroller, it is a chips where all instruction is being performed and executes okay by the computer. Okay? So yun. So microcontrollers, yan. Supercomputers, ito na yung pinaka near sa era natin ngayon. Okay? Supercomputer. Parallel processors, dito na actually nangyari yung dito na actually in this phase, dito na yung malalaking processors ng kuan natin, no? Computers natin. So we have here an example. We have Cosmic Cube from CIT, Intel's IPSC or Hypercube. We have here Cray Research Incorporated. Okay? So yun. So now, okay. So we have here types of computer. We have RISC processors. We have these types of microprocessor. We have the first one is RISC processors. The it it states here that reduce the instruction set computers. No, it reduces the instruction of computers. Okay, computers with a small number of instruction, and its opposite is a CISC, or complex instruction set computers. Okay, RISC is reduced instruction set computers. So basically these computers are the computers where you cannot input some instruction in which it is a complex, no, so reduce instruction set computers. And for CISM, which is complex instruction set computers, most probably maraming na handle to siya na instructions, no, even if it is complex. So here is the difference or the comparison between CISC and RISC. No, we have a large number of variables length instruction, whereas in RISC is all instructions are of the same length. No, so yun, pare-parehas yung length daw niya. Then multiple addressing modes, whereas in RIC is very few addressing modes, so maliit lang. A small number of internal processor register, so maliit lang yung number of processor niya. Then pero whereas in RISC is a large number of internal registers. Okay, so we have here instruction require multiple number of clock cycle for their execution, and its equivalent is its comparison with RIC is all instructions execute in a single clock cycle. Okay, so complex talaga yung CISC. No, kasi yung CISC is marami tayong clock, no? When you say clock cycle, those clock cycles is where um yung instruction natin is being executed based on that clock cycle, no? So kung isa lang yung clock cycle natin, kagaya dito sa RISC, so mahirap yung execution ng ating instruction, no? So yun yung difference ng dalawa. So we have here Intel's i860, IBM's PowerPC, DAC Alpha, EVF, EV5, and ARM7. Okay? Okay, so dito na ngayon si digital signal processors. Okay, so dito tayo sa bits, bytes, and hexadecimal numbers. A bit or a binary digit is a digit that can only be 0 or 1. Each group of 8 bits is called is a byte. So, ibig sabihin, those instruction that is composed of 8 bits is called as byte. Okay, so we have here an so that bit or binary numbers is actually has a conversion from its binary conversion into decimal conversion. Okay, so pakibasa na lang dito. For example, meron tayong 01, 011 binary numbers. We have to convert that one into decimal. So using this process here, okay, so we have an equivalent value of 11. Okay, then we have also here binary and hexadecimal conversion. So the same pa rin, no? When you say hexadecimal numbers, those numbers that is composed of 8 bits of no 16 bits of number. Okay, so yun.